colleague. Our next speaker is Emily Ravenscroft. She's a student at Stanford University and studying a software literacy.
I had no idea there were so many Pythonistas who didn't know regular expressions. There's a quote from someone, and of course I've forgotten who it was because I'm terrible at names, of that sometimes when you have a problem, you think, oh, I can use a regular expression to solve it, and now you have two problems. I'm sure Alex knows who that quote is from. This is a recent quote I saw on DevChecks about regular expressions in Python, talking about the convoluted loveliness, and it's the equivalent of taking a quality Angus beef burger and grilling it with cardamom and curry. It's complex, not what people expect, and an acquired taste. I consider that a very good description of regular expressions in Python. Now, the beginning of this talk is going to be all about why you don't want to use regular expressions if you don't have to, and why you don't need to use regular expressions. Because strings in Python have a whole lot of methods. If you've moved over here from Perl or from other languages and aren't aware of all of our methods, we have a lot that can help you out so that you don't need to use regular expressions a lot of times. Let's start with starts with. If all you want to do is find out whether or not a string starts with a certain letter, you can use starts with. There's a minor gotcha, and that is not that it is case sensitive, so if you're not careful, you might get a false when it's true. So you have to be careful about case sensitivity. On the other hand, both starts with and ends with do accept tuples as the value that you're looking for, so you can look to see if your string ends with a period or a exclamation or a query, which is really handy. There's a lot of is methods, is alpha, is num, things like that, is lower. In Python, they're pretty self-explanatory, but again, there's a few gotchas. For example, if you have the string m there and you look to see, is it alpha? Well, no. Can anyone guess why it says false?
Spaces.
There's blanks, there's white space. Those are not alpha. And why would e come up as false? E dot is all num. It's empty string. So it is not either an alpha or a number. Okay, replace can help you with some of those gotchas by simply replacing the empty or the white space with an empty string. That helps. It can also be used for simple substitutions, so again, you don't have to turn to regular expressions for this. Now, an aside. PyCon 3000 is bringing us a new way of doing string formatting to replace the horrendous old way of doing it, which I absolutely hated. The old way, of course, uses the %s and %d and all of that. The new way is so much nicer. It uses names. I like names. That's the Pythonic way of dealing with things as far as I'm concerned. So you can just give field names and use the new format method of strings, which exists in PyCon 2.6, but not 2.5, and will be in PyCon 3000. So get used to using this in your code so that in the future you'll be able to handle string formatting a lot easier. Let's go to finding things in strings, something that people use regular expressions for a lot. Find and rfind are very similar. They return the index of whatever it is that you're looking for. Index also returns the index. So, and of course, R means it's starting at the right. So what's the difference? If you use find, it returns -1 if it does not find what value you're looking for, where index gives you a value error. Count, well, it counts for you. So it can tell you how many e's are in this expression. If you want to count words, for a rough count, for things like just, okay, I have to write 1,000-word article and I want to make sure that it's not over 1,000 words, all you need is a very simple thing like len s.split, and you've got your count of words. However, if you need to be more accurate, or if you're dealing with things like very large strings, you wouldn't want to use this. And that's when we're going to be getting into regular expressions. Counting sentences. You can use a simple count with a period to look for the number of sentences that end in a period. Of course, if you want to actually look at the endings tuple that we had before, you get a type error, and that doesn't work so well. So again, there are ways of handling that, but sometimes regular expressions are easier. Yes, Alex? There's one after lamb, one after snow, and oops, I changed this slide to a exclamation point after I wrote the 3. Sorry. Oops. Sometimes fixing typos isn't fixing a typo. Thank you for pointing that out. So we did talk about split, and strip is nice because it can get all of those unsightly trailing white spaces and leading white spaces that you might not want on your string. It can strip them out. Split, the default is white space. You can also tell it exactly what you want to split on. And it gives you a list back, which you can then join back up with join. And you can see you can either join it with empty string, or with white space, or pretty much any other string that you want to join it. Partition is cool. I haven't used it much, but it's really cool because you can split things like, you can look for and you get the head, the split, and the tail, which is sometimes really handy and a good thing to know about. Actually, partition was in 2.4, I believe, and possibly before. It came up on my 2.4 box, so. In is very useful. It works in it works in strings, it works in a lot of things. So if we have Mary had a little lamb, and we look for it, hey, it is in Mary had a little lamb, its fleece was white as snow. The problem with this is, which it are we looking at? And as you can see by using a slice, we've got the wrong it. So sometimes you just gotta use regular expressions. There's a lot of times when you want to use them, if you're finding complex patterns, if you're doing computational linguistics, parsing XML, so there's a lot of reasons. So let's look at how to use regular expressions. Here's an example of finding it in this Mary Had a Little Lamb, and you see that we found it. Now, the way that you see that line where it says it equal re.compile, r, etc., I think the re.compile is really ugly, but it's useful. So it takes a pattern string and it makes an object from it. When you're compiling, you can sometimes give it flags that ignore case, or are verbose, or multi-line, and etc. We'll look at a couple of those as we go. There's a special regular expression syntax that's similar to Perl's regular expressions, very similar. And one thing I do want to note, you see on here where I wrote R before the quote it, always use R in your compiles. If you don't, when you use something like \b, which is for word boundaries, Python thinks you meant a backspace. So always use R. Just get into the habit and you won't run into problems. Here's some regular expression syntax. Anytime you look at anything on regular expressions in Python, you should get a lot of these and be able to look them up for yourself. We're going to be looking at a couple of these specifically, and I'm just putting them on the slide so that you can see them in one place. One of the things that I thought was cool is the /d there in lowercase and the /w and the /s. If you give them the uppercase versions of those, so /uppercase d, it means not whatever the lowercase one was. And that's something that's helpful to remember. The brackets there, so that's any of this set, you can give it a number of different things so that you can find them. It's basically like putting or. And there's some other fun little things there we'll look at, grouping. The look behind, I think it's really helpful, and we'll get to that. So I'm going to skip to the next slide, but this is out there and you'll see it. So how do we find it? And we don't care if it's lowercase or uppercase. So I talked about flags. The uppercase I or the ignore case, all spelled out, you can use in your compile statement. And that way, when you are using that object, it will not care about your case on what it's looking for. So, whoa, what did it just do? Sorry. Okay, complex patterns. Another flag that's really, really helpful, especially when you're maintaining code, is verbose. So if you look at this pattern here, can anyone besides Alex guess what this pattern is for? Well, not just. Exactly. Hex or octal or decimal, it basically is to find anything that is an integer. And you use verbose, you can list those out and use comments with ors, and you can actually see exactly what each of those patterns is for. So when you're maintaining your code later on or maintaining someone else's code, if they were nice enough to use verbose, you can see the regular expression and actually figure out what it's for. Yes, verbose means that you can actually put a comment there with the pound sign like you would normally use for comments. And you can use white space, it ignores any white space that's in there. Search versus match. Match only matches if your substring that you're looking for is at the very beginning of the string you feed it. Search matches it pretty much the first instance of the substring. And that's a difference that you might be useful. So if you're looking to see if there's any lowercase in your string and you use search, it will find if there's any lowercase in your string. If you use match, you'll see that it doesn't have a return object. What that means is there was not a lowercase at the beginning of your string. If you want to see what it's finding, you can use find all. And again, it makes a very nice little list for you that you can do whatever you need to. Of course, as you can see here, the find all for her found her within words and in various lowercase and uppercase. So if you want to do words specifically with word boundaries, /b is your friend. Put one at the beginning and at the end, and then you will find actual discrete words. rather than pieces of words. So back to our sentence counting example, which didn't work with the tuple. Here, remember I said that the brackets will find anything in those back brackets. So we've got the dot, we've got the query, we've got the exclamation point. We compile that, and now we can run the string, Mary had a little lamb, etc. in there, and find all of the punctuation that we used, and find out how many of them there were. If you want to find in a multi-line text, which is probably going to be more of what you're using, you have two ways of doing it, and they're sometimes hard to keep track of, which one is which, and so I always pull up idle and try it out to find out which one is which. And you can see here that if you're looking for uppercase its, one of them tells you uppercase its, that's at the beginning of the entire multi-line string only, and the other will tell you its is found at the beginning of any of these strings. This string is our Mary had a little lamb, its fleece was white as snow. So as you can see, the its find all that uses the little caret actually found it anywhere. The its A that uses the backslash capital A didn't find it because it was not at the beginning of the very first top string in your multi-line. Tokenizing is something that we do in computational linguistics. It's something we do with XML. It's something that PyCon parsers do for parsing PyCon. It separates it in stream into tokens. So let's look at and find all of the words in Mary Had a Little Lamb. All the separate words without the punctuation. And so we use this pattern, and we use find all, and we get all of the words, which I use dot 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 so that it would fit on the slide. But they're all separate, and they don't have any commas in there. It doesn't have any periods in there, and things like that to mess up your nice clean words. That's really helpful when you are looking at a corpus and doing things like trying to find out how many unique tokens are in that corpus. On the other hand, if it's a really big corpus, you don't want to use find all, because find all makes a list, and that will take up a lot of space. So use find iter, and it gives you an iterable that you can handle each one right after the other and feed it into a dict with the count and increment the count, so then you can find out how many times you used Mary or lamb or whatever. Substitution. Substituting one word for another is pretty easy with regular expressions. As you can see, you've got, it takes your string literal of lumberjack and the slash b's for the word boundaries, and then you tell it dot sub and what you want to substitute and what the string is that you're substituting into, and there you go, no problem. But what if you wanted to substitute I'm in this? You might want to substitute your uppercase or your lowercase, depending on where it is in the sentence. This is where look behind is really, really nice. You do it twice. You use your look behind to find the, that's in purple there, to find the period, a space, and I'm. Look behind does require a fixed length field, so if you think you might have some with a space, some with two spaces, you would want to use an or there so that you could do a single space or a double space after your period. And it finds you, all of yours that should be uppercased, you substitute that, and then you run through again, and you can substitute your lowercase ones. Yes. And the resources, Andrew Kuchling has a great page on how to regex, which is at this URL, and I have uploaded my slides to the PyCon so you can find it. Andrew Kuchling's is great. Rethinking Regular Expressions by Alex Martelli in the Python magazine, issue 66 is very helpful. Python Cookbook and Python in a Nutshell both cover regular expressions in Python. The regular expression pocket reference does have a section on Python, and it's very compact and useful. If you're into text processing a lot, David Mertz has a book on it that goes into this quite heavily. And if you're into computational linguistics, NLTK, the Natural Language Toolkit, is great for part of speech matching and all of the kinds of things you do in computational linguistics, and it's written in Python. Yes. Scanner is a very useful thing, and I'm not going to say anything more about it because it's really complicated, and everything you possibly want to know about Scanner is at this URL by FBot. So, that is my presentation. Questions?
You have 5 minutes for questions.
Something I've had trouble with Python regular expressions is kind of nested statements. Have you had any experience with trying to deal with? Sorry. So my question is basically, do you know of any good ways to deal with nested or looking for nested patterns with Python regular expressions? So like let's say nested tags, XML, or something like that.
There actually is an XML parser, and I would use that. That's already built to do that. So.
Next question.
Hi, what's the level of support for Unicode strings and parsing them with regular expressions?
I have not worked directly with it. I know there is some support, and I believe they're working on that for Python 3000, which will be backported to 2.6 as much as possible, so that I know there is some support for it, and I have not worked with it myself.
Back to the room.
So you said not to use regexes when you don't need to. What kind of performance hit are we talking about?
It's not so much of a performance hit as a readability hit. Regular expressions are basically, they're hard to read, they're hard to maintain, and as far as I know, the built-in string methods, if those are usable for what you are doing, will be much more readable, and will be perfectly good performance for you. If you have specific questions about performance on regular expressions, I do suggest that you talk to that man right there named Alex Martelli, who is very into it. The article by Alex.
Our article is, half of it is careful benchmarking of performance of regular expressions versus string methods. If you care about, it's not a microsecond issue, but if you care about nanoseconds, you really want to read it.
Personally, I've never had to worry about my nanoseconds.
Yes, we had a question back here.
I've used regular expressions a lot. Do you ever
And you
get
probably know more than I do.
well, maybe not, but do you ever get to a point where you say, even though I've invested a lot of time in this, I have to abandon this approach, it's not working for this current problem?
More often than I want to say. There's a reason that I avoided using them a lot, and the more I've worked with them, the more comfortable I am, but there's a lot of times where I look and see, is there a module that will just do this for me? Because sometimes it's not worth reinventing most of the time, it's not worth reinventing the wheel. If there's a module out there that already does it, I use that because someone much smarter than me already did all of the work to figure out how to parse XML, for example. There are times that it is very useful. I tend to mix regular expressions and build PyCon native string support with what I work with the computational linguistics, bigrams, hidden Markov models, and things like that I've worked with. And that seems to work well for me. So I try to avoid having to get too far into the real complexities.
We have time for 2 more questions.
This is a question, but there's a couple little tools out there where you can test your regular expression and get the result immediately. They're very useful when you're writing them, and they're always wise to test them in your code too.
Personally, I tested the things that I put in here with idle. Idle is your friend, but there are tools out there. Would you care to talk about the ones you're familiar with?
I don't remember the name.
I'm sure you can Google them and find out. But like I said, I just tend to test things in idle, just because it's right there, always with me.
I know there's one in on OS 10 called Reg Exhibit. That's the one I use.
Thank you.
More questions? All right, so, thank you.
Thank you all.